Hello, what's up? By the way, am I audible? Let me check the status. Mm, just a second, let me check the status if I'm audible or not. Hello, hello, hello. Yeah, I'm audible, but the sound is coming a bit slow. Is it? Yeah, now I think this is good, but as I don't, I'm not using, a headphone. That's why I might have to just, speak a bit first. Makes sense, right? So makes sense. So where were we? Yeah, we were just this problem. But one thing I just have seen that maybe I should have to increase the font a bit. Maybe this is good. Yeah, I think that's all. Maybe too much, or is it okay? Yeah, that's all. Okay, I just forget what the question was. Yeah. Given an increasing sorted array ARR with distinct integers, the array is right rotated k times. Find the value of k. Let's suppose we have an array 2469. Okay, if we rotate it two times, then it will look something like 9246. 9246. After first rotation, then yeah, I got it. So what it is saying basically, let's say I have like 2, 4, 6, 9, and after the first rotation, like 9 will come at first. So 9, 2, 4, 6. Second rotation, like 6 will come. I mean before 9. So 6, 9, 2, 4. So I have to calculate that how many time it is rotated. So let me go through an example. So it is like 5, 1, 2, 3, and 4, right? And the given array 5, 1, 2, 3, 4 originally sorted like as 1, 2, 3, 4, 5. We can see that the array was rotated one time to the right. Makes sense, right? So see, for this question there are a couple of things to be remembered. I have to calculate that how many times it is rotated. So for this question, like 6, 9, 2, 4, the actual sorted one is like 2, 4, 6, 9, right? So to find an algorithm that can do it. So the time complexity is O log n, but let me think about a brute solution or maybe any solution that I have to think of. All right, makes sense, right? Mm, so uh, well, how many times array has been makes sense, but I don't really feel that here I have to use 2469, right? So generally, if I do a binary search over here, so let me do a binary search over here. Let me do a dry run. Firstly, let me start the binary search. So, okay, there is my low, my high, and let me consider this as a mid. So, I have to find that which part is actually the sorted part. But still, I really uh, okay. So let me tell you the 2469 progression. Basically, this is if I consider I, if I consider J. So J should be like greater than I, right? But for this case, I mean, let me consider this as an uneven pair, like six, not basically this is an uneven pairs, 9 and 2. So if I, draw the progression basically, so it is like at first 6, then 9, then 2, then 4. So generally, this is the progression. It is uneven progression. So this time and this time it mhm. Oh, it makes sense. Mm, what I can do is let me dot size. And I will write a simple binary search to be honest. And if I have find the if nums of low is like is equals to nums of mid. Actually, to be honest, what I feel is this question cannot be solved using binary search. Is it? It is solved, but mm, okay. Really, so generally, what is my first approach? That is, times to the right. Okay. So let me start a timer and let me see how much time do I need. Okay. Okay. Mm, all right. So generally, after calculation of mid, I don't need really this. I need couple of pointers like. So let me tell you. Like I have 5 1 2 3 and 4. So when I'm standing at 2, then I have to know who is before 1, I mean before 2 and after 2. Like I need previous, also I need next, right? And this is, let's say, my element. Like I need previous and the next. So how to calculate the previous and the next? So can I say that algorithmically I can say next equals to mid plus 1, sure, and previous equals to mid minus 1, sure. So that is generally my think process for solving this problem right now. But yeah, if we can go through some more test cases, then we can surely find out that what's wrong with our thinking process. Okay, so int I'll say previous equals to mid plus 1, sorry, minus 1, and int next equals to mid plus 1. Okay, so now what I will say, what is condition? Basically the condition is, let me consider that I am considering for 1, right? So 1 before 1, before 1, let me consider mid as a so I think I can visualize over here properly. So let me consider this. Now this value, the previous value, and this is next. This is the element, or let me consider as mid, and this is next. Okay, if the next is less equals to mid, or mid is smaller than the next, let's say this is 12 and this is 24, and like previous is like 32, right? So that time I can say that the answer should be this. The mid. So let me tell you about my thinking process by take you through like 5 1 2 3 4. So let's say this is my mid. So these values should be less than, the thinking process is like I am getting at like this one should be lesser than everyone. This is the first apple that I have to take. Okay, so let me write this. So if array of mid is like less equals to array of like next, and array of mid is less equals to array of previous. If that's so, I will return mid. Okay, why I will take you through after a certain time. And so basically the thing that is, if array of mid is less equals to array of high, then I need like, I need more like in the left side, so I would say high equals to mid minus 1. Else I can say like low equals to mid plus 1. If nothing goes, I can return as what is minus 1 or 0. 0. Okay. This is all about my think process. So let me go to the input. Okay, so I have like 512 5 5 1 2 3 4 5 1 2 3 4 1 2 3 4 5. Also I need this one like 6 9 2 4 6 6 9 2 4. Number of test cases 3 1 2 3 4 1 2 3 4 5 1 2 3 4 5. Okay, makes sense. Okay, is it 9 or 10? Oh yeah, 10. CPP. Oops. That's 4 10. 210. Okay, let me see that 1050. Yes, that really go through. So again, you know one thing. Again, I am telling you that what about my solutions look like. It is pretty much straightforward. So let me do a dry run actually. So I think that you can understand that pretty clearly. Okay. So okay, my bad. So this is my low. Just 7. Okay, so I have like 5 1. Oh, let me take like a 2 example. 6 9 4. By the way, x17. Yeah, I'm going to. So like 6 9 2 4. 6 9 2 4. So this is my low. This is my mid. Sorry, my friend. This is my high. And for the time being calculation, this is my mid. Now, while checking that element that is, somehow getting this condition, so what I have to calculate? I have to calculate like in this position. I mean, if I consider this is mid, the both sides of mid is like, let's say this is previous, this is next. So like somehow like previous is greater than mid, also greater than next. So this is my like think process, even so if I'm considering like this trio, so like 6 9 and 2. So 6 is greater than 9 but not greater than 2. So this is not my answer. So if it is not my answer, what I have to check? I have to check a certain nice thing. I have to check like the mid is like normal binary search, the mid is 9 and I have to calculate with high. Are you greater than high? If you are greater than high, I mean what? If I need greater than high, then I should shrink to get. So I have to shrink the value. So I have to like high equals to mid minus 1. Oh, my bad, sorry. It is not true. It is less than. It should be less than, right? So it should come at this position. So low equals to mid plus 1, and yeah, that's what I want. So mid plus 1, like I have 2 and 4. This is my high and this is my low. So like this is 0 1 2 3, 2 and 3. So that, I mean, mid should be lie at here. So now calculate, let me. Okay, 2 and 4, here my mid is here. So when my mid is at here, and I have to calculate at 9. Okay, now I got a position. I got a position where I got like 9 is greater than 2, also greater than 4. Makes sense? So I can say, okay, this is my answer and the index is my value of k. Now this is a bit tricky. Now why this happens, I know there is some mathematical proof, but this is what it happens. Let me take you through a big example. I think for a big example this can be useful. Okay, so let me consider the array is like 1 2 3 4 5 6 7 8, and let me take me to like 5 6 7 8 and 1 2 3 4. Okay, makes sense. So how many times it is rotated? Actually it is rotated 1 2 3 4 times. Rotated 4. Okay, makes sense. So what I will do first, at first let me write them properly, like okay, this is my low, this is my high, and 3, like 0 1 2 3 4 5 6 7, like 0 1, like 7 by 2, like 3 is my answer. 1 2 0 1 2 3. This is my mid, and let me consider the quad, I mean trio. 7 8 and 1 doesn't follow because the, I mean, next is not greater than a mid. So if this is true, what I have to calculate, like when my mid is greater than, when my mid is greater than like the high, then I have to shrink to high zone. So the low should be mid plus 1, so it is like 1 2 3 and 4, and this is like low, high and mid. And for the index compulsive 0 1 2 3, like this is my mid, you can say by just seeing this. Okay, makes sense. Now can I say 2 1 3? It doesn't go through. It really doesn't go through. Okay, makes sense. So what I will do now, oh, 1 second, 0 1 2 3 4 5 6 7, 0 1 2 3 4, this is 4 5 6 7. Okay. So when like mid value is lesser than high, that is here 4, then I should move ahead with the right, I mean sorry, the left part, I mean this part. So now I will have 1 and 2. The index is like 4 and 5. Okay, 4 and 4 plus 5 by 2, 9 by 2 is 4. This is my low, my mid, my high. And if I calculate the trio, I mean trio, that is 1 2, what is before 1? Before 1 is 8. So I got 8 is greater than 1, also greater than 2. So I got the mid answer. This is my mid. What is my mid? The mid is 4. So Let me quickly write the code here. Okay, then I have to just write a simple binary search, and I have to calculate the mid is low plus high minus low divided by 2 if nums of, sorry, not nums, mid, array. If array, what I'm saying, if array of mid, okay, before that let me calculate the previous equals to mid plus 1, and int next is p mid minus 1. Okay, makes sense. Okay, if array of mid, what I'm writing here, if array of mid is less equals to, if array of mid is less equals to array of next, and array of mid is also less equals to array of high, not previous, then I will return my mid. Else, I mean, I have one issue. So if array of mid is less equals to array of high, what I will do, high equals to mid minus 1, else I will do low equals to mid plus 1. Yeah, makes sense. And I have one like 0. I'm at compile and run. Okay. By the way, guys, this is one of the, okay, I've gotten, okay. By the way, guys, this is a nice problem, though. Let me see that it did go through. Yes, compilation did successful. Okay, I'm getting a, possible code doesn't work with multiple test case. Okay, but the correct output is 62. Okay. Aha, let's say in a hypothetical way, I am getting like uh, 1 2 3 4, or let's say this is my low, this is my high. So that can I say that 1 is my answer? No, because nothing is before of low. So let me write that test case here. Okay, so if array of low is less equals to array of high, then I return just low. And I cannot check, by the way. Yeah, that was the test case that I was missing. So this was a nice problem. If array of low is less equals to array of high, should return the main, sorry, low. Make sense? Okay, next single element in a sorted array. So see, there are some pattern you have to carefully understand, that when there is written like single element in a sorted array, so binary search is the first choice you should put. But yeah, you are given a sorted array consisting only integers, but every element appears exactly twice except for one element that appears exactly once. Okay, I have to find. So generally let me write the test case for it. 11.cpp. You know one thing, when you are writing any problem, please create the test case, run the test case with your stuff. Don't rely on compilers. Yeah, sometimes people do rely on compilers for interview specific stuff, so in n. But I feel like if you are doing competitive programming, that also this this is important. Okay, add it, take the values. Okay. Okay. I have just int answer equals to add your nums. I have nums. Okay. So yeah, you have to change the name, but carefully should look like what is the names. Okay, return 0 to make sense. Single non-duplicate vector int. I haven't yet read the problem, by the way. Okay, the first solution. Okay, let me write the test case also. Input input okay, two test case I have. One, two, three, four, five, six, 7, 8, 9. 9 is my answer. Okay, makes sense. So the next thing is like this. Why my 3 is at I don't know. 1, 2, 3, 4, 5, 6, 7. Okay, so that's all my test case looks like. Okay, makes sense. So generally what it is saying, nice. So basically I have 1, 2, 3, I mean an array where everything stated in twice. I need ones, I mean one element. The first solution that comes in my mind is the XOR. Why XOR? Because the first algorithm that teaches that when there is like two same element, if I'm considering like 2, 2, 1, 1, 3, so then this will classify it as 0. This would classify themselves as 0, so 3 will return. So this thing that comes in my mind, so I will just n equals to nums dot size and just a simple iteration. I will say XOR1 equals to nums of I, print XOR1 equals to um, 0. Let me consider. I am not sure that 0 happens or not. So the answer should be return XOR1 C++ 11.cpp dash o11 11 and input 2 and 10 makes sense. Let me see. Yeah, 2 and 10. So this solution do work, but I will not submit this in lit code. It will work. So let me show you that he do submit. So if I just y this out and paste this, this will work. But if I submit this, I'll get a TLE, time limit exceed. Probably, not sure. Let me see. Oh, it did exceed and even it 0 millisecond, but this is not true. This didn't follow the requirements, and it's written completely clearly like I should make an algorithm that is big of log and with a big of 1 space. So I should use like binary sets. Why? Because I need like single element in a sorted data. There is so many sign of doing binary sets. So I 1 1 1 1 2 3 3 4 4 and 8 8. So let me assume that we're doing a binary search. So like this is my low. This is my bad. Why I'm writing mid again? This is my high. So 0. This is my mid. And so what I will see is let's say for the before question that what we're doing, we will do the same here. Like 3 3 4, I'm standing at mid. I will check the mid, is this guy same? Also there's an algorithm to solve this. Actually, I don't understand the algorithm clearly. Okay, let me write the solution again, like 1 1 2 1 1 2 3 3. Let me write like 4 4. Also write the indexes 0 1 2 3 4 5 6, and this is my mid. Okay, see one thing clearly. When this is my answer, can I tell one thing? That like mid should, I mean, if mid is equal to mid minus 1 or mid plus 1, then I can say like mid is my answer. And yeah, that's all I have to do. Yeah, that's all I have to do. I'm not keeping this brute force here to maintain. Low equals to 0. So before that, couple of things I have to calculate. Like, I am not really saying about I will do the whole thing. I will just consider this part. Why standing on here, I cannot check here also, okay, because I think that is the good way to do it. So I can, let's go through this, like lambs of 0 is not equals to nums of 1, and return 0 as my answer, and nums of n minus 1 not equals to nums of n minus 2, return n minus 1. Makes sense, really makes sense. Otherwise I will consider low as 1 and high equals to n minus 2, like one step ahead, and just a simple binary search, if mid or more nums of mid is not equals to nums of mid minus 1 and nums of mid not equals to nums of mid plus 1. Like I got like my nums is actually, so I will return nums of mid. Now which position should I trim? So carefully see this position carefully. Okay, so mid, this cannot be my answer. Now if I'll have like if mid ampersand 2 equal to 0, also nums of mid is not equals to nums of mid minus 1, or mid ampersand, yeah, you can write that one also equals to 1, and operator, that is cool also, and nums of mid not equals to nums of mid plus 1. If this is true, I will trim the left part. So trim the left. What do you mean by trim the left part? So low equals mid plus 1, else right mid minus 1, and if nothing, I will return minus 1 or 0. Let me see that it do go through or not. I am getting too much issue. Oh, so this is one problem that I get so many times. Okay, so write another one. I think some issue I'm getting with the parentheses. Yeah. Okay. So this is the parenthesis of this. This should not be the parenthesis of that. This should be the parenthesis of this. Terms of this. This is the parenthesis of no. This is the parenthesis of this. This is the parenthesis of this, as well as this is the parenthesis of this. Okay. Now I think it is. I have so many issues. Why? Okay, int main, empty parenthesis. Okay, int main. Oh, my issue. Why? Aha, my bad. My bad. Return 0. Oh, yeah, now I think this is good. Dot slash 11 input 210. Yeah, I think I'm getting correct answer. So just skp y and just paste this out over here. I don't know. What maybe? And yeah, it did go through. And okay, my bad. Okay, so you're getting like a heap of a flow. Um, aha. So for one, it will get a heap of a flow. So why? Let me explain you. You know, if I get like 3 and 1 and 1. So for this one, I will get a heap buffer flow. Let me show you. See. So generally for this case, I can, write one thing like at here, if like n equals to 1, I will return 0. I'm not quite sure that n equals to 1, return 0. So why actually happens? See, when I'm at 1, nah, so it is basically at 0th index, so it will try to find like what is 1th index, but there is no 1th index. So for that case, it can give you a buggy stuff. Okay, expected 1. Can I expected terms of okay, let me see that. I think I'm not so sure about it. Okay. Hmm. Ah, my bad, yeah. I'm sorry, yeah. Nums of 0, nums of n minus 1. Ho ho ho. Oh, why? No? Mhm. Yeah, now it is accepted. So what is the time complexity? Yeah, big of n log n. Sorry, log 2. I mean, log base 2. Okay, find the peak element. Oh no, you know one thing. This question I have done tons of time. Why? Because this is called peak element. I mean, this is a value and this is a value. I mean, the question that I did at maybe 10.cpp. Yeah, here the same thing I have to do there. Just changing the uh, equal sign. So 12.cpp. I so what is the constraints? By the way, is there any constraints? Okay, nums and yeah, that's all what I have to do. See what is peak element, like 3 is a peak element, like 2 and 1 are less than 3, so that is my answer. Okay, n vector int and I mean nums having n. Let's create a for loop. And answer equals to what is the value? Find peak element, something like find peak element nums. That makes sense. Hmm. So uh, see, there are so many stuff to do, but while low is less equals to high, int meet equals to low plus high minus low by 2 in previous equals to mid minus 1, sorry, previous equals to mid minus 1, my bad. Okay. What is the condition? The first condition is I have to check like for the mid. So if nums of previous is less than, directly less than, it's not like equals to. If nums of previous is less than nums of mid and nums of mid, let me write it in a parenthesis, nums of mid is greater than nums of mixed. If I got any like this position, I will directly return mid. Should I return mid or the indexes? Always considered to be okay. So there is one thing, it is written like let's say I have like 1 2 3 4, like whatever before that it is, I should consider minus infinity. Makes sense. Like let's say for I have 12 and all, so 12 is my answer. Makes sense. Okay. Okay, what is the next stuff I have to do? If nums of previous is greater than nums of mid, what I have to do? When the previous value is higher, let me consider, let's say 12, 13 and 1, and here it is my mid. When this is higher, drastically in which position I am. So if I'm considering like this, so I am considering like 12 is here and 1 is here, so it should be at the left part, right? So I have to go left, so high equals to mid minus 1 is my answer. So high equals to mid minus 1, else low equals to mid plus 1. So understand this carefully. This is the main image that you have to understand carefully. Let me consider like I have had this graph and this is my mid. Let me consider this is let's say 2 and this is 12. I'm not sure that 12 is my peak element. There can be something before than 12. Okay, so there is a possibility that before 12 I can get my peak element. No, because here I cannot get my peak element, so I will read. I should go to the left part. So this is the main funda. I know this is the main funda. So that's all. And if it doesn't, I should return minus 1. Yeah. Let me see what is by 1 2 3 1. Okay, GGBGB 1 2 3 1 4 1 2 1 2 3 1 1 to 1 1 to 1 3 5 6 3 5 6 and 4. 7 2 test cases is there. Okay, okay, something wrong is happening. Let me see what is. Okay. One thing I can write here, not okay, same thing. All right, let me do the same thing like the shrinking part. uh, if n equals to 1, return 0, or maybe nums of 0. And if nums of 0 is greater than nums of 1, then I should return nums of 0. Okay, I have to return index. So return 0, and same thing if nums of n minus 1 greater than nums of n minus 2, also return n minus 1. And right here 1, and here 2. I'm just assuming that it should be. Minus 1, yet it didn't go through obviously, because yeah. Uh, okay, mid equals to low plus 1, b equals. Not quite sure, man. Oh, my bad. Dot. You have seen I have written 12 cleared. Dot slash 12. Yeah, I am now getting segmentation error. So let me do like ltrace dot slash 12 dot c. So yeah, till then I'm getting something error for two test cases, 1, 2, 3, 4, 7 test cases, 1, 2, 3, 4, 5, 6, 7. Makes sense. N equals to 1 and then 0. If 0 is greater than 1, I'll return 0, minus 1, I'll return minus 1, 1, minus 2. Previous equals. Let me not write previous and all, right? I think that will give you us extra hectic. And here write mid minus 1. Plus 1. Mid minus 1. And let me see now, did it go through or not? No. Oh, oh, I haven't taken the value of n. That's why I'm thinking I should be having some problem with the input. You know, when I'm doing LTRS, I have seen the problem with it. My bad, yaar. When I did LTS 2.5, that is my answer. 2.5, yeah, that's my answer. Oh, bullshit. Okay, and peak element is done. Makes sense, makes sense. For the today we are like, so I think yeah, that's all for today. I have just solved the remaining part. Maybe the next day I have interview um tomorrow. So yeah. So yeah, goodbye. And yeah, that's all for today. Maybe if you want this code, I can just push that on my GitHub. But yeah, if you just want, you can just comment it out. Yeah, that's all for today. And stream, yes.